So what's interesting is that in recent time, there's been a lot of scientists who were non-believers, and as they were studying their field, they've come across things that made them stop and go, okay, this doesn't fit with the preconceived ideas about how life should have come into being and this whole evolutionary understanding of life. And it started a long time ago. In fact, I had my physics professor in college. I was startled because at the end, in one of the classes, I don't remember if it was at the end or whatever, but he basically gave his testimony. He was a Chinese man from China, an atheist, didn't believe in God, had no background in God or anything. He, as he studied, he was a physicist in looking at quantum theory and the whole Big Bang. When that was published and well thought about, as he was thinking about it, he realized that based on the laws that we know, if there was a Big Bang, then there was a point in which everything was a steady state. For how long, we don't know. And by all of the laws that we know about, there would be nothing that would then cause that bang to occur unless there was an external force that worked on this point of matter. And so something had to cause that bang. And so I have that under this evidence of cosmology, the Big Bang. And as he thought about that, and as scientists have looked about it, there's some serious implications to the Big Bang. And one of that is, and the reason they got there is by, they can look out at the stars and film them, and they look at the light, the color that they are, and they see the patterns of different, as stars burn, the various minerals and chemicals that they're burning, they have a signature, a light signature. So hydrogen has a pattern, and helium, and the different things have a specific pattern. So as they're looking at them, they're slightly shifted. The patterns are slightly shifted, and it's what's called the red shift. So things are shifted slightly towards the red side of the spectrum. And it's with light the same kind of effect that you have with the Doppler effect with sound. Have you ever noticed, like when a car is coming towards you, the car, it's making the same sound the whole time, but when you're standing there, it sounds like, because when it's coming towards you, it compresses, and so the sound is a higher frequency, and when it goes past you, they're decompressed and they're stretched out so that the sound waves are further apart and it sounds lower. So higher frequency is higher pitch, and lower frequency, lower pitch. Same thing happens with light. So the stars then, since they were red shifting, they could see, which is a shifting towards the slower side, they could see that the stars, no matter what direction you're looking at, they're all moving away. They're all moving away in every direction. Which, then, if you take that and go backwards, that means that everything all started at a single point. Which means that the universe, as we know it, had a beginning. Which, until the Big Bang happened, or not the Big Bang happened, but that scientists recognized that there was this beginning, they thought that the universe had essentially just always been. It's always been out there, and so that the theories of evolution the time scale is infinite. It had infinite amount of time to develop. Well, whenever you're talking about infinite, anything can happen, right? So, some guys were, when you talk about possibilities, when you look at quantum theory and look at how matter is made up, there is a non-zero possibility. There is a slight possibility that I could just go through this wall. Because after all, this wall is made up of mostly space between the atoms. In fact, I'm mostly space. I look like physical matter, but actually, if you go down to the atomic level, there's lots of space between the electrons and all of the atoms. So we're mostly space. And so there is a slim possibility that I could just go through the wall, right? So when you're talking on possibilities, well, and you're talking about infinite, then it's really hard to say, well, that's not possible because, well, given infinite time and infinite chances and infinite possibilities, one of those times I might just go through the wall. Well, we know, though, that I'm not going to go through the wall, right? Unless there's some supernatural thing going on, because there's other things at play. So we've never seen it. It's never happened except for in cases like where Jesus seems to have gone through walls and he defied the rules of nature. But so this idea that the universe had a beginning kind of shook people up, because now they're not dealing with infinite time, okay? They're dealing with a fixed amount of time for everything to develop. And so now that causes one problem. The next problem is this whole matter of, okay, well, what caused the Big Bang? So there has to be, by definition, something outside of the known universe, because the known universe started out as a point and it exploded, and it is exploding, and that's then formed all of the stars and planets that we know about. But there was something outside of that point that caused it to bang. And so, if you think about it, if there was that start, then sometime through history, all of the time before that, there's something outside who has the power. It couldn't just be a mechanical device, because if the property was always there with mechanical or chemical or other properties, if there was some property that had to be met before it to bang, right, then that condition was either always met or never met, or you have some variation. And so, but there wouldn't have been like some beginning if it was a mechanical device. There had to be, for anything that came into existence, which the universe has a measure, then there has to be something that causes it to come into existence, something that moves on it. And there's a whole scientific and philosophical concept behind this known as the Kalam theory of how, and it's not too far different from what our basic laws of thermodynamics or of thermodynamics say that all things will come to a steady state, one of the laws of thermodynamics. Other laws of motion as we know them, things that are bodies that are at rest will stay at rest until they're acted on. And things at motion will stay in motion until there's something that stops them. So another force, either friction or another force that's